Hi, welcome to the Olympiad geometry. Let's continue our study of the Menelaus theorem. Let ABC be an acute triangle. A1, A2 are on BC, B1, B2 are on CA, C1, C2 are on AB, and angle A1, A2 equals to angle A2, A1. So, and equals to angle B1, B2 equals to angle B2, B1 equals to angle C1, C2 equals to angle C2, C1. AA1, AA1, B1, C1 compose a triangle. So we can see it here. We can make it a bold line. And AA2, BB2, CC2 compose another triangle. The triangle is here. Proof: 6 convexes of these two triangles are concurrent. So we want to prove these 6 points are on the same circle. That if we just look at the figure, it has a symmetrical that we can rotate A to B, B to C, and C to A. Which means if we just replace A to C, B to A, C to B, it doesn't change any conclusion from the conditions. Which means that if we can just prove one triangle and another point, right? Because a triangle can define a circle. That means a triangle with another point are on the same circle, then 6 points are on the same circle. And from the condition we got, because B2, B1 equals to C1, B, this angle equals to this angle. That means the triangle AC1C is similar to triangle AB2B. So we have like this triangle here, and we want to prove this point or this point are on the same circle of this triangle. We can just connect them together. And we give these points names. Say here is U, V, W, X, Y, Z. The difficulty of this problem is that in a very standard figure, we can find that UY is actually look like in parallel with VW, which we can have a direction of the proof. But here I'll just write it. So we start from proving that UY is in parallel with VW. We can use Menelaus theorem. on the triangle ABA1 and line C1C, right? Because we want to find the ratio of AU to UA1. So for here we have AC1 divided by C1B times BC divided by CA1 times A1U divided by UA equals to 1. Because we want to find the ratio of we have the ratio of A1U to UA. We want to find the ratio of A2Y to YA. So we do the same thing, similar thing. We use Menelaus theorem on the triangle ACA2 and line B2B. So we have AB2 divided by B2C times CB divided by BA2 times A2Y divided by YA equals to 1. Let's call this first equation. This is second equation. So we can use the first equation divided by the second equation. That means we have AC1 divided by C1B times BC divided by CA1 times AU divided by A1U divided by UA times B2C divided by AB2 times CB. Oh no, this here should be BA2 divided by CB times YA divided by A2Y equals to 1. Right, we use the first equation divided by the second equation, we got this one. And we know that BC can cancel the CB. Now we want to find the relation of this one and this one. So we put them together and we put the rest of terms together. That means AC1 divided by C1B times B2C divided by AB2 times BA2 divided by CA1 times A1U divided by UA times YA divided by A2Y equals to 1. Notice that we want to prove the line UY is in parallel with the line VW in parallel with BC, right? So look at here. We got the ratio of A1U to UA times AY to A2Y. So basically, if we can prove this one equals to 1, the product of these two terms equals to 1, then we prove that UY is in parallel with A1, A2. And because these triangles are not unique, which means we can use a similar way prove that VW is in parallel with BC. So we can prove that UY in parallel with VW. So we want to prove this one, these terms equals to 1. So we have to prove the production of these three terms equal to 1. Let's look at it. AC1 divided by C1b times B2c divided by AB2 times BA2 divided by CA1. So AC1 divided by C1b and B2c divided by AB2. So we have AC1 divided by AB2 actually. AC1 divided by AB2, right? Because we know that we have the triangle AC1C is similar to the triangle AB2B, which means we can find AC1 divided by AB2 in another term, which we transfer it to AC1 divided by AB2, we transfer it to CC1 divided by BB2. This is useful. Why? Because BB2 equals to BB1, CC1 equals to CC2, AA1 equals to AA2. That's from the condition. We haven't used it yet. So keep it here, and we find the rest part that we have B2C, B2C, and CA1. So B2C divided by CA1. B2C and CA1. Because the triangle AA1C is similar to triangle B2C, right? That means B2C divided by CA1 equals to BB2 divided by AA1. So we have AC1, we have AB2, we have B2C, we have CA1, we have the rest part would be BA2 divided by C1B. BA2 divided by C1B. So we have triangle C1BC is similar to triangle A2BA, right? So BA2 divided by BC1 equals to AA2 divided by CC1. The production of these three will be CC1 divided by BB2 times BB2 divided by AA1 times AA2 divided by CC1. So AA2 equals to AA1, right? AA2 equals to AA1. And all other parts can cancel each other, which means the production of these three terms is 1. And which means here, the A1U divided by UA equals to A2Y divided by AY, which means UY is in parallel with BC. So we can also use A2, right? Use Menelaus theorem on triangle A2 and the line C to C. Also use Menelaus theorem on the triangle AA1C and the line B1B. Then we can get that VW is in parallel with BC, right? Got VW in parallel with BC. So that means we get UY in parallel with VW, XW in parallel with ZU, XY in parallel with ZV. So we got these two actually, this segment is in parallel with this segment is in parallel with this segment, this one in parallel with this one. Because this is manual draw, it's not good enough, so it's not clear that these segments are in parallel with each other, but we can prove it here. So how can we use this conclusion to prove that these 6 convex are on the same circle? So if we look at, because we have this line is in parallel with this line and in parallel with this line, which means the angle AUY equals to angle AA1, A2, right? This angle equals to this angle. And because this XW is in parallel with AB, so we have this angle is equal to this angle. Right, that means this angle, and here, also here and here, they are all equal. So if we look at UXV, triangle UXV, and point W, for example, then we actually looking at UXW V. So the angle because this one is in parallel with this one, that means here the YXB, angle YXB equals to angle BB1, B2, and this also equals to angle AUY, right? That means for the quadrilateral UYXV, right? For the quadrilateral UYXV, this angle equals to this angle. That means angle VUY plus angle VXY equals to 180 degrees. So they are concyclic. Similarly, we can prove all other points of the W and Z are on the same circle. So this problem is not that difficult. The issue that is kind of hard to prove is because from the figure, if it's a manual drawing, it's difficult to find that we want to prove VW is in parallel with UY and XY in parallel with ZV. It's difficult to find that and difficult to find the breakthrough point, but otherwise it's pretty straightforward. Okay. I hope you like this problem and see you in next video. Thank you.